Hello friends, do you know that if you measure volume of sand in different conditions, then that will show you different values? What I mean is, if you measure volume of dry sand and again you measure volume of same sand but this time in wet condition or damp condition, then that will show you up to 50% increase in volume, and that is called bulking of sand or bulking of fine aggregate or simply bulkage effect. So my name is Padi, and in this video we will be discussing everything about bulking of sand. That means we will be discussing why bulking happens, what are the factors that affect bulking, how to measure bulking of sand while on site, what are the effects of bulking on concrete, and how to make corrections for bulking. So watch this video till the end and we will be covering everything about bulking, and after watching the video till the end you will be able to understand everything. You will be able to answer all of those questions. So watch this video. So let's start with what is bulking and why it happens. So sand has a tendency to show increased volume when in damp condition or wet condition, and that is termed as bulking effect of fine aggregate or bulking effect of sand. Now why it happens? Because when we add water into the sand, then what happens? There will be a formation of water covering around the outer surface of each sand grain. It means if these are two sand grains, then there will be a water covering around this sand grain, and same thing will happen here, and as a result, instead of a close packing like this, they will repel each other. They will be apart from each other at some distance, and the repulsion happens because of phenomenon of water known as surface tension. Because of surface tension, instead of close packing, they will be separated from each other, and because of this there will be increased volume, and this is the primary cause of bulking, and that is surface tension. So remember this, the whole cause of bulking in sand is because of a phenomenon of water known as surface tension. So remember this one. Now let's talk about what are the factors that affect bulking of sand. There are primarily two factors that affect bulking of sand. The first one is size of sand, or else grain size distribution of sand. If the sand is more finer, then there will be more bulking. If the sand is coarser, then there will be less bulking. So you can say bulking of sand is directly proportional to the size of sand. If size is more, less bulking. Size is less, higher bulking. So remember this one. Fine sand will show you more bulking and coarser sand will show you less bulking. And the second factor is amount of water inside the sand. The quantity of water present inside the sand mass is responsible for how much bulking it will show. If you do an experiment, that means suppose this is your y-axis representing bulking of sand, percentage of bulking of sand, and this one is your x-axis representing quantity of moisture in sand sample. And now you start your experiment, and how you will do the experiment I will tell you later. Suppose you add in the dry, you take some dry sample and you added 1% of moisture in it, and as a result it will show you some bulking. So let it be 5%, and you gradually go on increasing moisture content like 1%, 2%, 3%, 4%, like you go on increasing moisture content, and there will be an increase in bulking. So 1% bulking is 5%, at 2% the bulking is 7%, at 3% the bulking is 10%. Likewise, the bulking will also go on increasing. As you increase water content, the bulking of sand will also increase, but that trend repeat itself up to a certain limit. What I mean, up to 5 to 7% of water content, there will be an increase in bulking, because your graph will go like this, up to 5 to 7% of water content. But after that, if you go on increasing water content, then there will be no more increase in bulking. Instead, it will gradually fall down like this. So it will start like this, it will go on increasing, but when the water content reaches 5 to 7%, there will no more increase in bulking. Instead, it will gradually go down, and it will reach a point when when it is zero, there is no bulking, and when it is completely saturated, it will come back to its original volume. And after that, no matter how much water you add, there will be no bulking. So remember, when the sand is in dry condition or the sand is in completely saturated condition, it will show you no bulking. So remember, this is a key thing to remember. When sand is in dry condition, it will show you no bulking. When the sand is in completely saturated condition, it will show you no bulking. So these are the two primary factors that affect bulking. Now let's start an experiment to show you how to measure bulking of sand, for which we need some equipment. First one, we need a measuring cylinder. This one is used to measure volume of sand, and the capacity of this one is 250 ml. This is another measuring cylinder, but this one is a little bit low capacity. It's 50 ml capacity, and this one we will use while measuring quantity of water that we will add into the sand mass, and a mixing pan to mix sand and water. So let's start the process. For the sake of simplicity, here in this measuring cylinder, I have taken exactly 100 ml of sand. Can you see this? This is here 90, then this is 100. I will mark it so that you can clearly visible. You can clearly see it. Now, see, this is 90, then this is 100. I have taken 100 cc of sand. Then I will mix around 5 ml. 5 ml of water means 5% of water. For 100 cc of sand, I am adding 5 ml of water, means 5% of water. Now we will add it. I will add. Let's put it back to the pan, and we'll add water into this sand, and we will mix it properly. So I will pause the video for a minute to mix it properly. Now the mixing is completed, mixing of sand. Now we will pour this sand and water mix into this measuring cylinder, and we will see what is the increased volume. It will take some time, so instead of unnecessary lengthening my video, I will pause it, and after insertion I will show you again. So now we have poured that mixed sand into this measuring cylinder, Now the volume of this sand is about here, that means 132. You see it? Can you see this? Previously it was here in 100, now it is 110, 120, 130 and it's a little bit upper, 132. So after adding only 5 ml of 5% of water inside the sand mass, we are getting 132. The volume has increased by 32%. As I told you earlier, sand when in damp condition can show up to 50% increase in volume. Now, how to calculate percentage of bulking? It is very simple. Now, the formula is volume of damp sand minus volume of dry sand divided by volume of dry sand. Now our volume is 132, volume of damp sand is 132, so 132 minus, we are taking dry sand of volume 100 ml, so 132 minus 100 divided by 100 whole multiplied by 100, and that will come 32%. So this sand when added 5% as a moisture, it's showing a bulking of 32%. Now the experiment is not over yet. Let's show you another thing. Now if I go on increasing water content, let's see what happens. I'll go on increasing water content. I'll add sufficient water so that this sand sample becomes completely saturated. Meantime, I will pause the video. I don't want to lengthen my video. Now you see, again after adding, it came back to its original volume as it was. So now the experiment is over. Now what to understand by this? Sand when in completely dry condition or completely saturated condition will show you no bulking. So while on site you have damp sand on site, so you first measure the damp sand, the volume of damp sand, and you add sufficient water to make it completely saturated, and so that it will come back to its neutral volume. That means same volume if you measured it in dry condition, and you divide that and you subtract that volume from the volume of damp sand, and you will find the percentage of bulking. So it's that simple. So let's start now. Let's talk about what are the effects of bulking on concrete. As you know that there are primarily two methods to batch concrete ingredients, or you can say to measure concrete ingredients, and the first one is wave batching and the second one is volume batching. While we are dealing with volume batching on site, we use a measuring box as a gauge to measure quantities of sand and coarse aggregate. For example, if as per design mix you need to add a cement, sand and coarse aggregate in a ratio of 1:2:4, which means for 150 kg bag of cement you need to add 2 measuring boxes of sand and 4 measuring boxes of coarse aggregate. But remember, this ratio has been fixed assuming that you are using dry sand, but actually while you are on site you found that your sand is in wet condition, and as I told you earlier, in wet condition sand has a tendency to show you increased volume. So when you are taking 2 measuring boxes of wet sand, you are actually mixing less quantity of sand. Remember this, because of bulking it will show you higher volume, but if you dry the same quantity of sand and you put it again inside the measuring box, then that will show you less volume, because the volume of one measuring box is equal to 0.036 cubic meter, and you take wet sand and you fill it up and you think that it is also 0.036 cubic meter, but you are wrong, because if you dry that same sand and you put it back inside the measuring box, then that will significantly reduce. The volume will significantly reduce. So remember that because of bulking, you may be using less quantity of sand, and as a result, your concrete will show you less workability, because sand is responsible for strength and workability. So if you are using less sand, then your concrete will be undersanded, and that will significantly affect your workability and strength. This is one effect of bulking. Another effect is, as per your design mix, suppose as per your design mix, you need to add 25 liter of water for every 50 kg bag of cement, and you added 25 liter of water, but there is also some water present inside sand mass, because your sand is in wet condition, because some water is there, and you are adding 25 liter of water, and again there is some water present inside sand. That means you are adding some extra water. Suppose let that water maybe 500 ml of water is there inside sand mass, then you are actually adding 25 plus 500 ml. That means 25.5 liter of water you are adding per concrete, and that will reduce what? Your compressive strength, because you are changing the water cement ratio of the mix design. You're changing because water cement ratio will directly affect the strength, the compressive strength of concrete. So you will not be getting the required compressive strength. So these are the two primary effects of bulking of sand. One is your concrete may be undersanded because of you are adding less quantity of sand, and another one is you are adding more quantity of water without subtracting the extra water you are adding. That means you are adding more quantity of water. So these are the two primary effects of bulking of sand. Sorry. Now we will be discussing how we can make correction for bulking while on site. So as you know that during volume batching, we use a measuring box as a gauge to measure quantity of sand and coarse aggregate. So this is here a measuring box, and the volume of a measuring box is equal to that of a 50 kg bag of cement, which is approximately equal to 0.035, as I have written down here, 0.035. And in some books it is mentioned as 0.036, but approximately it is equal to 0.035, and the dimension of a measuring box is equal to 27 centimeter, and the height is 48 centimeter. So you can prepare a measuring box with this dimension to get a volume of 0.035 cubic meter. Now let's talk how to make correction for that. Now before we make correction, we need to know what is the mix design proportions, and we will do it giving some example. So in our example, we have considered that we need to batch concrete ingredients in a ratio of 1:2:4. That means for one 50 kg bag of cement, we need to add 2 measuring boxes of sand and 4 measuring boxes of coarse aggregate. And always remember that this ratio has been fixed assuming that you are using your materials in dry conditions. So this is very important. That means you are using your materials in dry condition. Otherwise this ratio needs to be changed, and we will do it. So the first step you do while you present yourself on site, you to check your sand whether it is in damp condition or not, and if you found that it is in damp condition, then you go for testing for bulkage, how much bulking it is showing. So how will you do that? First, you take a measuring cylinder of 250 ml capacity or whatever is there with you, and you pour some damp sand. In our case, we have done it, and for example, we have found that the volume of damp sand is 240 ml. Then what you do, you add water into the damp sand so that it becomes completely saturated. So now it is completely saturated, and after some time the sand becomes settled and the mass, the volume reduced to be 200 ml. So what is the bulking? Bulking is simply 240, the volume of damp sand 240 divided by volume of dry sand or volume of completely saturated sand, because in both cases it will show you same volume. So in our case it is in completely saturated condition, so 200 divided by 200 whole multiplied by 100, so it comes out to be 20% of bulking. So as per our ratio 1:2:4, we need to add 2 measuring boxes of sand, which means we need to add 2 into volume of 1 measuring box is equal to 0.035. That means it comes out to be 0.070 cubic meter. But remember, this is in dry condition. If your sand is in dry condition, then you will add 0.07 cubic meter of sand. But while on site, you tested it for bulking and you found that it is 20%. So how much extra quantity of sand we need? Simply we need to calculate 20% of 0.070 cubic meter, and that will come out to be 0.014 cubic meter. So this much quantity, extra volume of sand we need to add inside the mixer. So how to calculate? Because we only have measuring box in our site, so how much quantity we put inside the measuring box so that we can be sure that this will become 0.014 cubic meter, whether we half fill it or we fill it up to 1/4 height. So let's calculate that one. It's very easy, because we know that formula for volume is equal to area into height. So we need a volume of 0.014, and we have the area of, as you can see, area of this measuring box is 27 centimeter into 27 centimeter. So we will convert it into meter, because in our case the volume is mentioned in meter, so we will convert 27 into meter. That means it will become 0.27 meter. So our area is 0.27 into 0.27 into h, because we need to calculate up to what height we need to pour sand, and so our height will become 0.014 divided by 0.27 and 0.27. If you calculate it, then it will comes out to be 0.0729, and after dividing it will come out to be 0.192 meter or 19.2 centimeter, or you can simply add or say just 20 centimeter. So now your height comes to be 20 centimeter. That means after adding 2 measuring boxes of damp sand, you need to add extra sand, and that extra sand up to height of 20 centimeter. Suppose this one be 20 centimeter. So again, up to this much height of sand you need to add extra, so that you will adjust for bulking. So this much of sanitary you need to add extra. So now I hope that you understand how to make correction for sand. The next thing is how to make correction for your water, because as per design mix you need to add exactly 25 liter of sand. We are talking just taking an example. So in this example we need to add exactly 25 liter of sand, 25 liter of water for each 50 kg bag of cement. So how? But we know that we are adding 25 liter, and in our sand that we are adding, that also contain some quantity of water. So let's start how to do that. I will show you. So as per our mix design, though we need to add water up to 25 liter water for each 50 kg bag of cement, but we are adding 25 liter plus we are adding damp sand. Damp sand means what? Sand plus water. So along with this 25 liter of water, we are adding some extra water. So our aim is to find out how much this extra water is, and after finding it out, we will deduct that much of water from this 25 liter, and we will find the exact quantity of water we need, and for which we need to first quantify how much extra water is there inside sand. And for doing this, we need to take some wet sand sample, we need to dry it, and then we can calculate what is the percentage of moisture content. But just think that whether is it possible to send that wet sample to laboratory for oven drying, and you need to wait for some time and the result will come, but that will kind of delay your activity, delay your progress. So instead of doing that, that is a smart way to measure the percentage of moisture present inside sand, and that is done by a chart, and that is so I have prepared a chart, and similarly you can prepare the chart for the sand you are using. So here is the chart that I talked about. So this is a, you can call it a calibration chart. So what this chart is all about, in this chart, for every 1% increase in moisture, I have tested it for how much bulking it is showing. When it is in dry condition, when the sand is completely dry, that is moisture content is 0, it show no bulking. That's why if the point comes here. When water content is 1%, the bulking is 23. The bulking is 23, so the point comes here. When the water content is 2%, the bulking is 32. Likewise, I have measured percentage of bulking for different percentage of moisture content, and I have so many points here you can see. After, you also need to do the same for the sand you are using on your side, because as I told you earlier that depending upon the size of sand, your percentage of bulking may vary, because finer sand will show you higher bulking, coarser sand will show you less bulking. So beforehand you need to prepare a chart like this. After getting all the points, you need to draw a smooth curve that will complement all of the points. Don't just add all the points. That is not done, because that will not give you a smooth curve. We need a smooth curve. So let's see how I'm drawing it. So it may or may not touch all the points, but that will complement all the points. So here I go. Here I go. A smooth curve. Draw a smooth curve using pencil.
here I am using pen, but this is not good. So a smooth curve you need to draw. So after drawing smooth curve, now you have this chart with you, and how it will be helpful for you, because as we have tested our sand for bulking, and we found that the bulking comes out to be 20%. So in this x-axis we need to find out where 20% is. So this is our percentage of bulking. So 20% is here, you see 20% of here. So extend a line, and where it crosses this curve, from that point draw a vertical line, and the point where it is crosses this x-axis, that will show you moisture content in percentage. So you can see the x-axis represents moisture content in percentage. So here you can it is coming out approximately 1%. So see 1%. Again, one more thing, if you extend this line, then also it is crossing at this point. So there are 2 points. If you draw vertical line to the x-axis, then it is approximately showing 35%. So which one to choose, 1% or 35%? At 20% of bulking, because at higher value also it will show you 20%, at lower value it is also showing 20% of bulkage. So which one to choose? And from my experience I am telling you that you first hold that sand sample with a palm and squeeze it, and you after then you throw it away, all the sand you throw it away, then you check your palm. If you see visible moisture in your sand, then that will come higher point, that means higher percentage of moisture content there. And if there will be no water in your palm, over your palm, and there will be no sticking of sand grains in your hand, it will all fall down, then that means it is on lower side. So if that is the condition, generally it will come on lower side only. So we will take 1% and we will calculate like that. So let's know that from the chart we found that for 20% of bulkage, the percentage of moisture content is 1%. So as per our mix design, we need to add 2 times measuring boxes of dry sand volume. That means 2 into 0.035 cubic meter of sand, that means 0.070 cubic meter of sand. So we need to calculate 1% of 0.070. So 1% of 0.070 will comes out to be 0.00070. This quantity of meter cube, which is equal to approximately equal to your, if you convert this one into ml, because 1 cubic meter, or remember that 1 cubic meter is equal to 1000 liter. Remember this. So this will comes out to be 0.7 liter, 0.7 liter, or you can say 700 ml. So this much of extra quantity of water is inside the sand. So as per our design mix, we need to add 25 liter of sand, but in sand it is already 700 ml of water is there. So we need to deduct this amount of water from this. So 25 liter minus 0.7 liter, it will comes out to be how much? 20 24.3. Yes, 24.3 liter it will come out to be. So this is the exact quantity of water we need to add for each 50 kg bag of cement. So now you understand how to make correction for a sand, how much extra quantity of sand we need to add, and how much quantity of water we need to subtract from the given quantity of water. So that's it.
So if you like this video, then do subscribe to my channel and share this video with all of your colleagues and friends. And one more thing, don't just listen to the information I have shared with you in this video, but apply it, because knowledge is experience, everything else is information. So if you want to improve your knowledge, then you need to apply this information on your day-to-day activities. Otherwise, it will not stick to your mind. So have a good day. Bye-bye. Subscribe to my channel. Share it as much as you can. I will see you in my next video. Till then, bye-bye.